So now that we've learned what conjugation is, we can also talk about what conjugation is not. And conjugated systems are broken by sp3 hybridized carbons. So what have we already seen with conjugation? Well, we've seen that we can draw resonance structures to demonstrate conjugation. We drew this earlier where we showed a resonance structure, those two pi bonds, which demonstrates that those two pi bonds are connected. This is an overlap of 4 different p orbitals. And when we draw the resonance structure, moving electrons like I show right there, we show that because this resonance structure is possible, that must be a conjugated system. So how do things change for this molecule over here? Okay, well, what if I were to try and draw an arrow like that? So what I want you to do is take a moment, draw the structure that arrow implies, and then try and determine why, if it's an okay thing, if it's an okay thing to draw. So do that, pause the video, I'll restart it in a moment. Okay, you restarted it. So this movement of electrons that I showed there would imply that it's okay for me to now draw this structure here. But we have a couple complications. Well, we took electrons away from there. We placed extra electrons on this carbon atom. So that would imply that there must be a negative charge on that carbon because it gained electrons and it lost nothing. And another thing about resonance structures that we know is that if this resonance structure is neutral, all other resonance structures have to be neutral, just like we saw here. This is neutral. There's a negative and a positive here, which cancels out, makes it neutral altogether. Well, how is this bad? Well, turns out that this is a skeletal structure that implies 2 different hydrogens right here, and those hydrogens mean that carbon atom right there must be sp3 hybridized. So what about sp3 hybridized carbon atoms? Well, if we have an s orbital and 3 different p orbitals, how do we make sp3 orbitals? We hybridize all of them. So it goes from a carbon with these individual orbitals to a carbon with 4 sp3 orbitals. If it has 4 sp3 orbitals, it can't have any p orbitals, right? It can't have any p orbitals. So if it has no p orbitals, it can't be conjugated. It can't have overlap with those p orbitals because you need a p orbital to overlap with other p orbitals. Okay, that's part 1. Part 2 of why can we just tell that this structure can't be right? Well, there were 2 hydrogens there. Nothing happened to those, so they would have to also be in this structure. So now that we see that, what's wrong with this structure? This carbon has 1, 2, 3, 4, 5 bonds. This is, again, as I've called it in the past, a Texas carbon. Texas carbon. Why do I say that? Well, everything's bigger in Texas, right? Well, not carbon atoms. We can't have carbon atoms with 5 bonds. Carbon only has 4 bonds at a maximum, and this has 5 bonds, so this structure is garbage. So all that is to say that conjugated systems are broken by sp3 hybridized carbon atoms. If you're an sp3 hybridized carbon atom, by definition, you don't have any p orbitals, and you can't have conjugation. How is that shown in your note packet? Well, let's first look at this structure here. In the electrostatic potential map, we see that the red area shows electron density. And the electron density on this butadiene molecule, the one we see right here, is localized kind of just all throughout the middle of the molecule. That tells us that there is substantial electron density, not just there and there, but also in the middle of those 2 pi bonds. Again, we see that by the red color of that electrostatic potential map. What about this one that's broken up by that sp3 hybridized carbon? Well, we see red color over here for electron density, and red color over here for electron density, but not really in the middle, and that's because it's broken up by that sp3 hybridized carbon atom. So take-home message, sp3 hybridized carbon atoms, we can't draw resonance structures around them. We can't have any conjugation around them because they don't have any p orbitals.